Have you ever wondered how your favorite app just knows what you like? Or how a giant online store keeps track of, well, everything? Well, the answer is kind of hiding in plain sight. Today, we're going to pull back the curtain on the tech that basically runs our digital world, databases, and the special language we use to talk to them, SQL. I know what you might be thinking, a database? Me? But yeah, it's absolutely true. Whether you even realize it or not, you've been using databases all day long. They're not just for some giant tech company in Silicon Valley. They are a huge part of our everyday lives. I mean, just think about it for a second. That shopping list you made for the grocery store? That's just a collection of related info. And your phone's contact list? Yep, same deal. At their very core, these are just simple, everyday databases. And that's really all it is. A database is just any collection of related information. Could be on a piece of paper, could be in your head, or it could be on a computer. But what happens when that simple little list needs to handle, oh, I don't know, a lot more information? Okay, this is where it gets really interesting. The huge difference between your personal shopping list and the database for a global company like Amazon all comes down to one massive challenge, the problem of scale. So your shopping list has, 10, maybe 20 items on it, and if you lose it, hey, no big deal, right? But then you have a company like Amazon. They need to store and get to trillions, with a T, trillions of pieces of data. We're talking user info, products, reviews, you name it. And that data is super valuable, so security has to be rock solid. You just can't do that on paper. That's why we use computers. They are built for this kind of thing, for keeping track of unbelievable amounts of information. So, how in the world do computers handle this insane amount of information? The secret is structure. Instead of just one giant, messy document, we use a system that's kind of like a perfectly organized digital filing cabinet. And that's what we call a relational database. Honestly, the easiest way to picture it is something you've probably used a million times, a spreadsheet. All the information is put into these neat tables with columns for different types of info and rows for every single entry. All right, check this out. Here's a super simple example, a student table. You can see the columns define what we're tracking, student ID, name, and major. And then each row is its own unique entry, a single student in our digital filing cabinet. But wait a second. What if we have two students named Jack, and they're both biology majors? How do we tell them apart? Ah, that is where the primary key comes in. It's a special column that gives every single row its own unique ID. In this student table, it's the student ID. And this is so important. Even if all the other info for two students was exactly the same, their primary key, their ID, will always be different. It makes sure we can tell every single record apart, no exceptions. Okay, so we've got this amazing, super organized, incredibly powerful digital filing cabinet. That's great. But how do we actually talk to it? I mean, we can't just ask it questions in plain English. We need a special language, one that the database understands. And that language is SQL, which stands for Structured Query Language. You can think of it as the universal translator for databases. It's the standard way we tell a database what to do. To create new records, to read the ones that are there, to update them, and even to delete them. So, let's say you have trillions of pieces of data. How do you find the one thing you're looking for? You definitely don't want the whole database dumped on your screen. You want a tiny, specific little piece of it. Well, to get that, you have to write what's called a query. Now, I know, at first glance, this might look like a bunch of scary computer code. But trust me, it's actually more like a really specific set of instructions. A query just tells the database exactly what you want and the rules for finding it. See? When you break it down, it's almost like plain English. We're just saying, select the name column from the employee table where the salary is more than $30,000. It's an incredibly powerful and precise way to ask for exactly what you need and nothing you don't. Okay, so we've gone all the way from a simple shopping list to writing these things called queries. But why does any of this actually matter? Well, because this whole system of tables and languages, it isn't just some abstract idea. It's the invisible engine that's running the entire modern world. Hey, remember that problem of scale we were talking about earlier? This is it. We're talking about trillions of pieces of information. SQL is the magic wand that makes it possible to search through all of that unimaginable complexity and find the one specific thing you need, one order, one user, one product review, in just a fraction of a second.
Every single time you scroll through your social media feed, check your bank's balance online, stream a movie, or buy something from a website, SQL is there, working hard in the background. It's fetching your data, finding your friend's new post, processing your payment. It is, and I mean this literally, everywhere.
When you really stop and think about it, everything from the simplest list to the world's most complicated apps, it's all just a collection of related information. It's all data. And with a language like SQL, we have this incredible power to ask that data anything we want. So that leaves me with one last thought for you. The modern world is built on data. What questions would you ask it?